This is a complex fraction when you have a fraction within a fraction. So there's a fraction in the numerator and a fraction in the denominator. That's called a complex fraction. And there's two ways to simplify this. If there's only a single fraction, like there is in both the numerator and the denominator, the easiest way to simplify this is to flip this upside down and multiply it, because this is a division, and dividing you multiply by the reciprocal. So I'm going to change this to a multiplication and put x over 6. And then I'm going to cancel. 6 goes into that once, into that twice. And so we end up with 2x over x minus 1. And that's it. For number 5, again, we just have a single fraction in both the numerator and the denominator. So I'm going to take the denominator and I'm going to multiply it and I'm going to flip it upside down. And then I'm going to cancel. K's cancel. And 2 goes into 2 once but into 4 twice. So I end up with 2k plus 1 over 3k minus 1. And that's it. Again, we just have a single fraction in both the numerator and the denominator. So I'm going to change this to a multiplication by flipping over the second fraction, 15 over 12x squared z to the 5th. All right. Now, 4 goes into 4 once, but into 12 3 times. 3 goes into 9 3 times, and into 15 5 times. Let's see. 2 of these x squareds cancel with 2 of these, making that an x to the 4 minus 2 is 2. And 2 of these z squareds cancel with 2 of these, making that a z to the 3. So putting it back all together in the numerator, we just have 5x squared. And in the denominator, we have 3 times 3, which is 9. And we have z to the 3rd power. And that's it. Okay, this problem's a little tougher because we have multiple terms in both the numerator and in the denominator. So when you have multiple terms, what you're going to do is figure out what the LCD is. So you look at all the denominators. The only denominator we have is x, so the LCD is x. And then you're going to take that x and you're going to multiply by every term in all of the fractions. And then you're going to cancel. This cancels, and that's it. So you're going to end up with 1 plus x in the numerator and a negative 1 plus x in the denominator, and that's all you can do. Okay, we have a x, a y, a x, and a y, so the LCD is xy. So I'm going to take xy and I'm going to multiply it by every fraction that we have. And then I'm going to cancel. This x cancels with this x, this y cancels with this y, x cancels with x, and y cancels with y, and we're going to be left with 3y plus 3x in the numerator over 3y minus 3x in the denominator. But this isn't simplified because we can factor. In the numerator we can take out a 3 and we'll be left with y plus x. In the denominator we can take out a 3 and we'll be left with y minus x. And now these 3's can cancel, so you're left with y plus x over y minus x. And that's the final answer. Okay, here's our main fraction bar, and there's just a single fraction in both the numerator and the denominator. So I'm going to flip this upside down and multiply it by the numerator. But I'm going to factor this while I can. So I'm going to have 8 parentheses x minus 3y over 10. That's the top fraction. The bottom fraction, I'm going to change it to a multiplication by flipping this upside down. So I have 5x over x minus 3y. And then I can see the x minus 3y's cancel. And 2 goes into 8 4 times, but into 10 5 times. And finally, this 5 cancels with this 5. So everything but 4x is canceled. Okay, here we have just a single term in the denominator, but we have multiple terms in the numerator, so I can't flip this upside down. I have to multiply every fraction, this, and this, by the LCD. And the LCD is xy. So I'm going to multiply this by xy, this by xy, and this by xy. This xy cancels, this y cancels with that, and this x cancels with that. So I'm going to be left with x squared minus 16y squared over x minus 4y. But this is not a simplified fraction because this can be factored. This is the difference of two squares. This is x squared minus 4y squared. So we're going to get the conjugate pairs in the numerator. We're going to have x plus 4y times x minus 4y in the numerator. And we have x minus 4y in the denominator. This entire factor cancels, and so our final answer is x plus 4y. Okay, I have multiple terms in both the numerator and the denominator. So I need to multiply each of these terms by the common denominator, which is 9y. Now this is about to get a little complicated looking, so I'm going to write my fraction off. I'm going to take my 9y and I'm going to multiply by this y minus, and I'm going to take my 9y and I'm going to multiply by this y minus 3 over 3, and then I'm going to take my 9y and I'm going to multiply by 4 over 9 plus, and I'll take my 9y and multiply by 2 over 3y. Okay, so I'm going to get in the numerator, for this I'll get 9y squared. Over here I'm going to cancel. 3 goes into this 3 times, and when I distribute, I'm taking the negative, the 3, and the y. All of that is going to distribute to here. So negative 3y times y is a negative 3y squared, and negative 3y times negative 3 is a positive 9y. Down here, I'm going to cancel. That cancels, and I get 4y. Over here, I'm going to cancel the y's, and I'm going to say that 3 goes into 3 once and into this 3 times. So when I multiply here, I get plus 6. So let's simplify this. I've got 9y squared minus 3y squared is 6y squared plus 9y. Now this looks like I can factor. So I'm going to take a 3y out of the top, and that's going to leave me with 2y plus 3. And I'll take a 2 out of the bottom, and that's going to leave me with 2y plus 3. And then these can cancel, so I'm left with 3y over 2. That was a tough problem. Okay, here I have my main fraction bar, so I have multiple terms in both the numerator and the denominator, so I can't flip anything upside down. I have to multiply by the LCD. I have to look at my different factors of denominators. I have an x and an x plus 2, and those are different, so my LCD is the product of those two things. Okay? So I'm going to take that LCD, x times x plus 2, and I'm going to multiply by each one of the things in the fraction. So I'm going to multiply first by x plus 2 over x. That's this. Then I have plus, and I'll have my common denominator, and I'll multiply by the next thing, 1 over x plus 2. Oops. And then I have my common denominator, and then I'm going to multiply by this, and then I'll take my denominator, and I'm going to multiply by this. And then I'm going to start canceling wherever I can. So this x cancels with that. This x plus 2 cancels there. This x cancels there. And this x plus 2 cancels there. So what I'm left with is the binomial x plus 2 times x plus 2, and I have to FOIL that. My first, I'm about to run out of room here, but I'll try and squeeze it in. My first is going to be x squared. The outer is a positive 2x, the inner is a positive 2x, and the last is a positive 4. And then I'm going to have plus x times 1, which is just plus x. That's the numerator. In the denominator, I'm going to take this 5 and distribute it through there, and I'll get 5x plus 10 plus, and then I'll take x times x, and we'll get x squared. So now I'm going to combine like terms. I have x squared, 2x, 2x, and 1x is 5x, and plus 4 over, and down here I've got x squared plus 5x plus 10. Now you may notice that this numerator, this numerator is factorable as x plus 4 times x plus 1. But I don't need to factor it because this denominator is prime. And because I can't cancel, there's no need to actually factor. If you did factor this because you weren't sure, that would have been fine. But this is the final answer.